Hello, today we're going to have a look at how we calibrate our balances. In this case we've got two digital balances. This is a 100 gram balance that weighs to 0.01 grams, and this one weighs to 500 grams to 0.01 grams, which means that they have an error of less than 0.01 of a gram. Now there are two ways of calibrating them. Okay, the first is to use the electronic calibration for the balance, and that means that we're going to push and hold the mode key until it says calibrate. We push it again and it will flash, and then it should come up with a required known mass. In this case it's 100 grams. And what we would then do is place on a calibration mass of that weight. Now a calibration mass is a specifically very accurately made weight. So in this case we have a set here. Okay, there is a 1, a 2, a 5, a 10 and a 20 grams. Now these must be very carefully handled, because any muck, any dirt or any scratching or anything like that will affect the mass of these weights and therefore the accuracy of our calibration. So we've got some special little tweezers for which we can handle the masses very carefully with. So we would put the 100 gram calibration mass on and let it calibrate, and then it would ask for a second or a third one, and so it would internally be creating a calibration graph. The other way to do it is to create your own calibration graph. Now this would be used for scales that don't have digital calibration or for analog scales, and this would basically involve zeroing the balance, making sure that it's on a level, stable surface, because any motion or vibration will affect the readings that you get. On some of our balances, particularly our more advanced balances, you'll find that they have a built-in spirit level which will enable you to make sure that the balance is completely level. If the balance isn't completely level, there'll be an unevenness in how it weighs and how the sensors within the balance pick up that weight, and therefore you will not get a true mass of your substance or whatever you're weighing. So it's important that it's on a level, stable surface. Once we've done that, we take our calibration weights. Now this one actually is calibrated so that we know it actually works. But we would put on the 1 gram mass and check that it reads 1.01. Okay, now that's telling us that it's calibrated at 1 gram. We would go up through our calibration weights, making sure that it's in line. So in this case I'm going to just put the 20 on there, and it reads 20.000, so that we know that it's calibrated. If it wasn't calibrated, which we've got with this one here, we would have to create a graph. So I'm going to put on our 1 gram mass. Now our 1 gram mass weighs 1.01 grams. You may want to write this down. The little one is super fiddly. Our next one is a 2 gram mass, and that weighs 2.02 grams. Then we've got a 5 one, which weighs 5.05 grams, a 10 gram, which weighs 10.1 grams, and a 20 gram one, which weighs 20.20 grams. Now we would take that information and plot it into a graph. Then, for example, with this, if we put something on here and it said it weighed 10 grams, we would go to our graph and we would go across and see that actually it didn't actually weigh 10 grams, it weighed 9 0.91 and a bit probably, because we're taking into account that error. Now this error on this balance actually turns out to be a nice error because it's nice and easy and it's linear, which means that it's even throughout. So in this case, for every 1 gram, it's increasing itself by 0.01. If it wasn't linear, and this is where the graphs become very important, is if, for example, one was added 0.01, but at 5, instead of it being 0.05, it might be 0.1 or 0.10. Sorry, 0.15. And then back at 20, it might have gone down again. And that's very bad news when a calibration isn't linear. So you've got enough readings there to have a go at drawing a graph, and therefore you can create a calibration graph for this balance. What's also important to remember, and this is why we were talking about linear, is that this calibration, because we're using 1 to 20, that would only work for things within 0 to 20 grams. We couldn't put something at 50 grams on this, having used this calibration method, and then take a reading off it, because we haven't calibrated it beyond 20 grams. Alright, thank you very much.